Everybody, it's Professor Mitchell. We've made it to the last section of Chapter 11, which is 11.6, Further Graphing of Quadratic Functions. In this section, we will not exactly write quadratic functions in this form, but we will do something that's kind of related. If you're doing the homework out of the textbook, I think they have some problems like that, but we're not going to worry about that. We're going to derive a formula for finding the vertex of a parabola. And then we're going to find the minimum or maximum value of a quadratic function. And this is still SLOC, which is constructing graphs of, in this case, nonlinear functions. All right, so here are a couple of easy conceptual questions. You might even be able to figure out these answers without picking up a pencil. How many X-intercepts and Y-intercepts does a parabola have if its vertex is in quadrant 4 and the parabola opens down? And then we'll do if the parabola is in, if the vertex is in quadrant 3 and the parabola opens up. So starting with letter A, try to picture that. First of all, which quadrant is quadrant 4? Put the vertex of your parabola there, and then have your parabola open down. How many X-intercepts would that parabola have? Okay, picturing that. I'm going to switch over to my tablet, just in case you're having trouble picturing it. All right, so quadrant 4 is this quadrant over here. So let's put the vertex anywhere in quadrant 4. And it doesn't take me too long to figure out that if my parabola opens down, I am not going to have any X-intercepts. Okay. Now, how many Y-intercepts am I going to have? Well, I wouldn't call that a trick question. I would call it an easy question, though. Maybe so easy it's hard. Every single, let's call it vertical parabola, a parabola that opens up or down, has exactly one Y-intercept. Okay, which kind of makes sense from the standpoint of just thinking about the function. You know, f of x equals ax squared plus bx plus c. The y-intercept corresponds with the point where x is 0. So putting x equals 0 into that function will always give you automatically one y value that goes with that. So no matter how they mix these up, quadrant 1, 2, 3, 4, parabola opens up or down, there will always be one y-intercept. Okay. So we'll consider that our warm-up. Remember the second question, how many intercepts does the parabola have, both x and y, if the vertex is in quadrant 3 and the parabola opens up? Okay, so hopefully you don't need to draw the picture this time. Quadrant 3 is over here. Let's say my vertex is right here. And as soon as you tell me my parabola opens up, that automatically means there are 2 X-intercepts. And as always, 1 Y-intercept. Okay. So consider that to be our little warm-up. Let's go back to the presentation. Okay. All right, so back to the vertex of a parabola. Remember from the last section that if the parabola is written in the form y equals a times x minus h squared plus k, that the vertex of that parabola is the point hk. So what if the quadratic equation is written in this form, y equals ax squared plus bx plus c? Well, I don't want to bore you with all the details, If you get really curious, ask me in the discussion for your online class. I would be happy to explain it there. So it is possible to take an equation that's in the form y equals ax squared plus bx plus c and rewrite it in the form y equals a times x minus h squared plus k. It involves completing the square. And it's similar to the derivation of the quadratic formula that I showed you for exactly 2 minutes back in section 11.2. It turns out that when you do that, h always comes out to negative b over 2a. So take that to be a formula for the vertex of a quadratic function that's written in this form, y equals ax squared plus bx plus c. All right, so to find the vertex of that parabola, first find the x-intercept, which is negative b over 2a. Now, if I really wanted to, I could give you a formula for the y-intercept. It is easier to just tell you to take your x-intercept and plug it back into the function. That's the easiest way to do it. All right, so let's do an example. Finding the vertex of the graph of this quadratic function. Switching back to the tablet. Okay, so first we're going to find the x-coordinate of the vertex. Remember, we're finding the vertex. We're going to do, I would say, 3 more examples of this. All right, so first step is find the x-coordinate, which is negative b over 2a. So let's identify a and b. Then negative b over 2a. Let's write this as negative blank over 2 blank. B is 6, a is negative 3. So that's going to be, let's put the negative up here, negative 6 over negative 6, which is 1. Okay, so that means the vertex is 1 comma something. To find the something, we'll just plug 1 back into the function. Okay, so let's write the function as negative 3 blank squared plus 6 blank plus 4. So that's going to be negative 3 plus 6, which is 3. 3 plus 4 is 7. The vertex of this parabola is 1, 7. All right, so let's see. I could probably just stay here on the tablet because I think I remember what's coming next. Yep, I was right. Okay, so just like last time, what I want to do now is switch over to my lab and walk you through a couple of those homework problems. Okay, here we go. Starting with number 12, they want me to find the vertex of the graph of the quadratic function, determine whether the graph opens upward or downward, find any intercepts, and then sketch the graph. Okay. All right, so I did my homework this time and I wrote all of those questions on the tablet. I could not remember exactly what they asked, so I wanted to look. Here we go. So first it's asking for the vertex. So this is the same thing as what we just did. A is negative 3, B is negative 12. So the x-coordinate is given by x equals negative b over 2a. All right, so we put the negative 12 there, the negative 3 here. So the top comes out to 12, the bottom is negative 6. X comes out to negative 2. All right, so the vertex is negative 2 comma something. And to find the something, we are going to put negative 2 into this function. All right, So what's that going to give us? The square of -2 is 4. -3 times 4 is -12. That's going to be plus 24, so the y-coordinate is 12. The vertex of this parabola is -2, 12. All right, the next question is, does the parabola open up or down? So you remember this cute trick? That still works in this section because the a in y equals ax squared plus bx plus c is exactly the same a that's in y equals a times x minus h squared plus k. It will literally be the same number no matter which form you write that in. So in this case, a was -3. That means the parabola opens down. All right. Next question, find the intercepts, the x and y intercepts. Let's start with the y-intercept. Feels like it's been a little while since we talked about this. The y-intercept is the point where x equals 0. In other words, what happens when you put 0 into the function? Well, in this case, everything comes out to 0. All right, so the y-intercept of this graph is 0, 0. 0, 0 is a very special point. It happens to be my favorite point. Whenever 0, 0 is a y-intercept, it also gets to be an x-intercept because it's also on the x-axis, right? However, there may be other x-intercepts. A parabola can have as many as 2 x-intercepts. So for the x-intercept, you set y equal to 0, which remember is the same thing as setting f of x equal to 0. So we're going to take our -3x squared minus 12x equals 0, and we're going to solve that. So that is a quadratic equation, and I think we can solve it by factoring. If I factor out -3x, that leaves me with x plus 4. And if -3x times x plus 4 is 0, the only way that could happen is if -3x is 0 or x plus 4 is 0. Okay, now this is about to get a little messy. If -3x is 0, you know what, I'll color code this. That would have to mean that x is 0, and we already knew about that point. If x plus 4 is 0, that means x is -4. We did not know about that point. So there are 2 x-intercepts. There's the one we already knew about, 0, 0, and there's also -4, 0. Okay, so now we get to draw the graph. Just like in the last section, I'm going to encourage you to draw it on paper before you do it on the computer. Now, it may sometimes happen that you decide you don't have quite enough points and you want to maybe check one more, and I really encourage that. I think that's a great idea. Let's see, what points do we have so far? We have -2, 12, and we have 0, 0, and -4, 0, okay? So first of all, that means I'm going to have to scale my y-axis a little differently. I think I'm actually going to go by 3s so that I make sure I can get that 12 in there. Okay, but the x-axis I'll leave the way it is. All right, so we have -2, 12, which is up here. We have -4, 0, and we also have 0, 0. I think I would like to see just one more point. Let's see what happens when x is -1. right? So the function was f of x equals negative 3x squared minus 12x. If we put in negative 1, that is going to give us negative 3 plus 12, which is 9. All right, so that's going to go right here. And remember my symmetry. I don't know if it's going to ask me for the axis of symmetry. I have a feeling it won't this time. But your axis of symmetry would be right here. And that helps me understand that if I have this point, negative 1, 9, then I also have this point over here. Okay, so now I feel really comfortable drawing that parabola. It's going to look something like this. All right, so now let's do it on the computer. All right, here we go. Okay, so first the vertex. The vertex was negative 2, 12. Woohoo! Does the parabola open up or down? It opens down. Wait a minute. Oh, you know what? Oh, they tricked me. I assumed that answer A was up and answer B was down. Oh, rats. Okay. All right. Well, lesson learned. Don't let the same thing happen to you. All right. So I guess if I want full credit on this problem, I'm going to have to do another one from scratch. But let's just continue. The X-Intercepts. So let me really pay attention this time. They want ordered pairs. So I'm going to select option A. And I'm going to get one ordered pair, which is 0, 0. And then I'm going to put a comma out here. And I'm going to ask for another ordered pair, which is negative 4, 0. Okay. Still can't get over that opens up or down thing. You all heard me say it opens down. And then I went and picked it opens up. All right. Okay, so it liked the X-intercepts though. Y-intercept, we know there's always one Y-intercept, and in this case it is 0, 0. All right, and now I think we are ready to draw the graph. So let's pop this out. I'll ask for my parabola tool. I will go to the vertex at negative 2, 12. And then you can click any other point that you know is on the parabola. We have like 3 choices. I'm going to go with, no, I guess we have 4 choices, but I'm going to go with 0, 0. All right. This time it's not asking for the axis of symmetry, so we should be done. Woohoo! There it is. All right. So now let's go to number 14, which I hope is the same as when I looked at it before. It is. All right. Actually, if it wasn't, that wouldn't be too big a deal because I haven't done the work yet. So the same question, and this time the function is f of x equals negative x squared minus 6x minus 13. So going back to the tablet. All right. Any day now. There we go. All right, so the vertex, we need A, which is negative 1, right? And B, which is negative 6. X equals negative B over 2A. Ooh, I think we're in for triple negative here. Guess we had that in the last problem too. All right, this comes out to 6 over negative 2, which is negative 3. So now I just have to put that number back into the function. Okay, -3, -3, -3. Be careful with your signs. The square of -3 is 9, but there is an extra minus sign outside, so this is a -9. This is plus 18, minus 13. That comes out to 9 minus 13, which is -4. The vertex is -3, -4. All right, now the infamous does it open up or down question. A was -1, so this one also opens down. And I am really going to pay attention this time when I answer that question on the computer. All right, intercepts. I'll start with the y-intercept again. Set x equal to 0. I'm actually going to tell you about a little shortcut for y-intercepts. We're just replacing x with 0. So look what happens when you do that. The first term comes out to 0. The second term comes out to 0. All you're left with is that -13. Whoops. Which happens to be the value of c in ax squared plus bx plus c. See this? I could have put c equals -13 here. So take that as a shortcut. I'll put it up here. The y-intercept is always going to be, when it's written in this form, is going to be 0, c. All right? And again, that's if it's written in the form ax squared plus bx plus c. All right, now I'm going to do something sneaky for the x-intercepts. Remember our easy warm-up questions at the beginning? Let's see if we can use that to save ourselves a little bit of time. The vertex of this parabola is at -3, -4, which is in which quadrant? -3, -4 is in quadrant 3. And the parabola opens down. Can you picture that? Well, if the vertex is in quadrant 3 and the parabola opens down, that automatically means you have no x-intercepts. All right. So this is definitely going to be, oh, I'm sorry. Before we go on, I wanted to write the y-intercept as an ordered pair. The y-intercept would be 0, -13. Okay, so we only have 2 points. We have the vertex and we have the y-intercept. I do not feel comfortable graphing with so few points. So let's get at least one more. Yeah, I think one should do it. Okay, and if we're going to get the point 0, -13 on here, we're going to have to scale again differently. I'll go by 3s. Okay, so this is -3, -6, -9, -12. All right, we have -3, -4, which is going to be right about here. And we have 0, -13, which is right about here. Okay. Why don't we see what the value of the function is at -2? Remember, the function was -x squared minus 6x minus 13. If I put a -2 in there, that is going to give me square of -2 is 4. The extra negative sign leaves it negative. -4 plus 12 minus 13 is -5, isn't it? Yes. Okay, so that means that this parabola passes through the point -2, -5, which is right about here. And because of the symmetry, I know about two other points that are on this parabola. We're going to have this point over here. And we're also going to have this point is the mirror image of the y-intercept. All right, so this parabola ends up looking something like this. All right, so now let's draw it on the computer. And I know I'm going to get that opens up or down question right this time. Still haven't gotten over that. All right. Okay, so what was the vertex again? It was -3, -4. All right. Okay, the parabola opens downward, which is again choice A. It is not always going to be choice A. So you have to read it. Oh God, I'm nervous. Okay, there we go. I was like, did I screw it up again? Okay, next. X-intercepts. Remember, there were no X-intercepts. So this time I'm going to choose that. The Y-intercept, though, is 0, -13. All right, and now we are ready for our graph. Okay, vertical parabola tool. Start with the vertex, which is -3, -4. And I guess I'll plot the y-intercept as my other point right there. Notice there are no x-intercepts. Woohoo! All right. Back to the presentation. To finish this off. Oh, wait a minute. Didn't have to do that. Just have to go. Okay, sorry. There we go. Okay, last question. The Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by this equation. And they have two questions about this. First, find how many calendars must be sold to maximize profit. And then find the maximum profit. Okay, so back to the tablet. All right, so P of X equals 360X minus X squared. Remember that X is the number of calendars. All right, and P of X is profit in cents. You might think it seems silly to write it in cents instead of dollars. If we wrote it in dollars, we'd have a lot of decimals. All right, so it's their way of trying to keep the numbers nice. How many calendars must be sold to maximize profits? So what you might find with these problems, first of all, as soon as you see the word maximize or minimize, that means think vertex, because the vertex always occurs at as a maximum or minimum point. Okay, so the word maximize or minimize means vertex. Now, it's not always going to be obvious. Are they looking for the x coordinate of the vertex or the y coordinate? Well, in this case, I look at the question, oops, sorry. How many calendars? How many calendars is x? So this is looking for the x coordinate of the vertex. So I break out my formula, x equals -b over 2a. Let's identify a and b. So be careful. Notice the form that they wrote the function in. It's not standard form exactly. If you rewrite it like this, you might find that helpful. A is -1 and B is 360. All right, so we have 360, -1, that is -360 over -2, which is 180. In order to maximize profit, they need to sell 180 calendars. All right, and then the second question, what is the maximum profit? Well, remember, profit was P of X, also known as Y. So for that, we're just going to plug in the 180 into our profit function. 360x minus x squared. So we just found out that the way to maximize this is to make x equal 180. Okay. I think I had better use my calculator for this. All right, 360 times 180 is 64,800. And 180 squared is 32,400. 64,800 minus 32,400 is 32,400. And what were the units for that again? They were cents. All right, which is $324. All right, that's going to do it for section 11.6. That's going to do it for chapter 11. Guess what? We only have one more long chapter, and that's chapter 12. And by the time we finish chapter 12, it'll be almost the end of the semester, and we'll just do 2 sections out of chapter 13. See you next time.